A quadratic equation has a single variable, and the equation includes a square term. Solving a quadratic equation involves finding the roots of the equation. In this video, we'll look at how to solve quadratic equations. Let's start with an example. The path of a certain fireworks rocket is modeled by this function, which shows vertical height in feet as a function of time in seconds. Y equals negative x squared plus 20x. At what times is the rocket at ground level? The rocket is on the ground when the y value is 0. The equation we want to solve is this. Negative x squared plus 20x equals 0. One way to solve a quadratic equation is to graph the original function and see where it intersects the x-axis. Here is the graph. You see that it intersects the origin, here, and x equals 20, here. Here are the labeled points. The roots of the quadratic equation are the x-intercepts. It is where negative x squared plus 20x equals 0. So the roots of the equation are x equals 0 and x equals 20. This means that the rocket hits the ground after 20 seconds have elapsed. Let's look at another example. The possible areas for a rectangle are modeled by the following quadratic function. Y equals x squared minus 13x plus 36. What are the possible values for x that result in an area of 6 for the rectangle? We take the quadratic expression x squared minus 13x plus 36 and make it equal to 6, the area of the rectangle. We rewrite the equation to get this quadratic equation in standard form. X squared minus 13x plus 30 equals 0. One way to solve quadratic equations in standard form is to use the quadratic formula. The values for a, b, and c come from the coefficients of the quadratic equation. With the equation we're trying to solve, we have an a value of 1, a b value of negative 13, and a c value of 30. Plug these values into the quadratic formula to find the roots of the equation. The b value of negative 13 goes here and here. The a value of 1 goes here and here. The c value of 30 goes here. Simplify the expression and we get two roots, x equals 10 or x equals 3. We can test each value for x in the quadratic equation we solved to ensure that in each case we get a value of 0. Plug in x equals 10 into the quadratic and the result is 0. The same happens with x equals 3. Let's look at a final example which builds on what we just solved. The possible areas for a rectangle are modeled by the following quadratic function. Y equals x squared minus 13x plus 36. What are the possible dimensions of the rectangle of area 6? We can rewrite the area equation to have a value of 6 this way, but we want the left side of the equation to look like the product of two binomials, as shown here. If we can find values for a and b, then we can find dimensions for the rectangle. Looking at the coefficient of the x term, we see that it's negative 13. And looking at the constant term, we find that it is 36. To find the values for a and b, find two numbers that add up to negative 13 and whose product is 36. The two numbers that do this are negative 4 and negative 9. So we can rewrite the factored form of the quadratic this way. We also know that the values of x from the previous example, x equals 10 and x equals 3. Plug in those values to see the possible values for the length and width of a rectangle of area 6. And we see that with x equals 10, we have a 6 by 1 rectangle.